Hey everyone, this is Evgeny, and today we continue building our MCP servers. And this time we will take a look at something very different. We will be using TypeScript instead of Python, and we'll try and start to build a very new thing which is really real. Alright, what kind of problems we are trying to solve today? And this is about providing LLM additional information. Let's say I'm working on this project. This is our MCP, but it doesn't matter at the moment. And the thing is that this is a company and I'm part of the team, and we had discussion. For example, we had some materials somewhere in a lot of systems, and when I'm working with LLM using Cursor, for example, this information is not part of the project, so I cannot reference it with making any decisions. And for example, if I type something very natural, in this case, for example, previously we had an agreement. It was yesterday, I remember about that, and I had some ideas in my mind, but we documented it in somewhere in our documentation system, like a file system. It could be Google Docs, it could be Confluence, a Notion, and the discussion was about reorganizing backend system. And I would like to start working on this, but I would like LLM be aware of our discussions. So that's my prompt. Basically, I'm trying to push it to the right direction, so check our last decision, and so we can start the discussion. And that's pretty expectable, right? The only thing LLM can do for you is to look through the existing code base and try to fetch this information from the code base. And it's not here. That's the expected result, and so it's going to check multiple places, but nothing is here at all because it's pretty logical. The information is in Confluence, for example. So this is the problem we are trying to solve, and the most straightforward approach would be to probably enable all different MCPs that allow you to do the search in Confluence, in Notion, in Jira, in Google Docs, to let the LLM to trigger all of them one by one and trying to fetch the information. But we have another idea. So the thing we are going to work today, and this will be only the first step, because we will try to build the proper system, and this is a really big and huge task for one small single video. But the whole idea would be to create our own, let me make it bigger, MCP server. And this one would have multiple plugins to different external systems, like we have Jira, Confluence, Notion, it could be Slack, GitHub, GitLab, Google Docs, and many others which you might come to if you have it in your company, for example. And think about that. For example, Google Docs, or it's very interesting because it's very often, if you have meeting in your Google Meet, for example, then you could have automatically generated transcriptions for you from the Meet application, and these will be stored in Google Docs. And so you can fetch this information from Google Docs to MCP and return to LLM, and then LLM is aware of all the discussions, all the conclusions, all the decisions made on this meeting. This is a really great idea. And again, going back to the straightforward approach, why cannot you just implement or configure multiple MCP servers? And this is why, because first, it's a very dynamic system, and just imagine, in general, when you're communicating with Cursor, for example, you have to pay for every call made to MCP server. And you have, I don't know, 10, 15 systems, you have to pay for every single call, and doing this multiple times. So the idea would be just to have a general KnowFlow MCP which knows about everything, and it's a very generic way. And then you can configure multiple plugins. And if you have a new system in your organization, okay, you just add a plugin and your MCP is ready to fetch it as well. So the only response from this MCP call would be to provide you, based on the request, provide you valuable information from multiple sources. And talking about requests, we're allowing LLM to generate the request. So for example, in this case, this is Jira, so it says it's project 5342. And we also asking LLM to define the potential system. And this is exactly potential system, meaning that LLM thinks that's probably Jira, but maybe something else. So we are still going to go through all the sources of information, but we will rate Jira maybe higher and return the results back. So that's the raw idea we are trying to implement, and we are starting in this video. Alright, let's go to the code, and I mentioned that already we will be using TypeScript this time, not Python as previously, and well, I think this is the case for most of us. We kind of used to this schema that backend is normally Kotlin Java and frontend, and the new way of building backend as well as Node.js with TypeScript and JavaScript. And well, sorry data engineers, but we're using Python only for learning this stuff, and here we are creating something real. So we are picking TypeScript this time. And let me just go quickly through all the important components here. And first of all, we need to add the dependency for TypeScript SDK to building our MCP server. And we need Zot library for generating the comments for our parameters and for validating the input parameters, the ones that LLM sends us as a request, as a part of request. We are starting from our index TypeScript, and this is pretty straightforward, I would say. So it's here, we are importing stdio server transport, and again, at the moment we have two ways how you can run your MCP server. The easiest one is running it locally, and then communication happens via standard input-output streams, and for that we are defining this server transport. And the other way would be to run it as a server in remote mode, and then we would use SSE protocol. It stands for server sends events, but we are not doing this at the moment. And then what happens next, we are importing server from the definition of server, and I will show you it in a bit later. We connect to the server providing the transport, which is again standard input-output streams, and practically that's it. Then we are printing that our MCP server is up and running. Alright, and next piece we need to think about is server. And again, we are starting here from creating a skeleton application, so we don't have any plugins in place. It's really overcomplicate our video at the moment. We only construct something which we can run and see that the whole approach is working. So what do we have here? We are defining MCP server, and this is the same dependency SDK TypeScript we already imported. We have Zot for validating our input parameters, and what's happening here, we're defining a server. And for our server, we're defining a single tool. Server tool here is a function. And here we're defining the function name, which is a search knowledge. We are defining the definition of this function. And this is very important. I am repeating myself, but because this is important, I have to do this. The LLM, the model, takes the function name, the tool name, and the tool description to better understand what capabilities this tool provides and when it's possible, when it's a good idea to run the tool to get some knowledge or to perform some actions. Then we are defining 3 parameters, and practically we are taking the query itself. And again, we provide a description of this query, and this is a search query to find, wait a second. The search query to find relevant information. Then I mentioned we have a system and the preferred knowledge system of source to search. And there are some options available to LLM for better understanding. And if specified, results from the system will be prioritized. But again, if specified, if not, it could be skipped completely. It's optional parameter. And we are providing a limit, default to 3, how many results we are returning back. So this block defines the parameters of this function. And again, the description goes to the model, so the model can recognize why it needs query system and limit. And next, we're defining the method for this tool, method body itself. And again, we have query system limit. We are deconstructing it from the JSON. And we are doing some logging as well. And again, I also was mentioning this in previous videos. Since this is the communication via standard input-output, you are not allowed to use these channels for logging, for example, because you would break the whole communication happening there. That's why we're using console error here, and we're just logging that we received a search query and with these parameters. And then we don't do anything really useful. We're just returning dummy response, because we want to see how the whole thing works, if it works correctly at all, right? We need to do this as a first logical step. And this is the result. We are providing the content, kind of was fetched from the real data, and we do have some metadata. We are saying, okay, this is source, and in this case, this is a physical file, but could be a document in Confluence, for example, or the URL for a Jira ticket or something else. The system itself, last modified, we are providing as well, because we have a hope that if the model gets multiple documents with different last modified dates, it can prioritize it based on the date. So the newer probably file or piece of information contains more actual information, something like that. And we do some rating as well. And the idea, we can apply multiple ideas here later, but one idea could be, for example, if the preferred system is Jira, then we can raise the confidence for Jira responses here. And finally, we are returning back the content and as a text, as a raw text. So we are packing our JSON to string and returning back, and that's it. It's pretty straightforward, pretty simple implementation of the MCP server so far. So let's quickly check if it's running still, if we don't have any compilation errors. And it's here. And then in these sessions, we'll be running our MCP using Node, not npx as expected for MCP servers that based on TypeScript. And this is a very temporary thing because we are in very active development of this MCP, and we'll be running it in kind of development mode. So once we are ready, once we're stable, once we have a list of proper plugins, for example, then we would pack it as a package, publish it, and then we would it will be possible to use our MCP as running npx command. But so far we are using Node before that, right? So what's happening here, it's pretty expectable. If you check again the index, once our server up and running, we can see this KnowFlow MCP server running on STDO, and this is what we can see here. So our server is running and listening for events. But since there is nothing it was configured to, there is nothing happens, right? So it's okay for us to stop it. And before you configure your MCP server to a real system like Cursor, it makes sense to check in general how it looks like. And there is a tool for that. It's called MCP Inspector, and we can always run our MCP server using this MCP Inspector and check the interfaces, check the behavior, check how it works, etc., etc. And this is pretty simple. You can find this in the documentation for SDK, but in general we are running as a package inspector, and we are providing the way how to run our MCP server. So the way it works, it starts, it's up and running, and it provides you the URL. This is the web interface to it. So let's give it a try and check. And here we are. We have MCP Inspector 082, the transport type STDO, as I mentioned already, and as I see the second one possible, but we are communicating via standard input-output streams. We have the comment and arguments already. We can define environment variables, some configuration, and when we are ready, we can click on Connect and run our MCP. So here we have the console, and again, since we are printing our console to here, it will be here, and our KnowFlow MCP server is up and running. What can we do here? We have a list of tools, and the first thing which happens when you connect your MCP to a client such a Cursor, it lists all the tools, so it knows the possibilities. Let's do this. And we can see here was a call to our server list tools, and this is the JSON that was sent to our server, and this specific method. This is RCP calls in general. And back we have the definition of tools and a single tool at the moment, right? And here we have some details. Like we can see the input parameters, properties, definition of them. For example, the description comes here, and that's why the model knows when to run it and what to put into the parameters. And this is the way how it works. What else can we do? We can execute the tool itself. So it's here. I'm clicking on it. There are parameters. So the description is here. Parameters are here, and let's type something. This is a dummy server response, so we don't care much about what's the queries, right? And I'm running the tool, and it's another call here in history, and we see that this is a tool call, and the tool name is search query, and the query is here. And the response we have, and this is our dummy response we generated, right? Or we can see it here as well. So we have a content, and we have a metadata, and all the parameters. So the first logical step when you build your MCP would be to run inspector and check how it's behaving And I think it's now time to give it a try here in Cursor LLM. And for that, we're going to Cursor settings, we're going to MCP, adding a new one, and defining our KnowFlow MCP. And again, we are using Node for development time. Later, it will be packed as a package, as a standalone package, and we will be using npx. And here, take a look, we have the definition for the function name, and we have definition for all the parameters, and this allows, again, the model, it gives the model understanding which and in which way this tool can be used. And let's try and repeat our query now and see how it works. If it works better this time. This is the main question we want to know. So for that, I am copy-pasting the same request. Will the result be different? This is the main question here. And see, it says, okay, I'll help you research and search through the knowledge base to find information. And there is a intention to make a search knowledge tool call. And it defined the query, backend system, reorganization agreement, documentation. And there is no system, so it's not clear for the LLM which system is that. Oh, which system could be that. It's a general query. We run the tool, we get back the results. And it says, okay, based on the search results, you can see that there were 2 key decisions documented, so it's kind of working. And then it decided to make another tool call, backend monorepo implementation plan X structure. And I think what's happening, the information is not enough to make further decisions, so I decided to make another call to the tool and fetch the information specifically about this monorepo using an X, whatever it was. I have no idea. But it will not work because we have dummy responses all the time, right? And that's it. But anyway, you saw the decisions were here and they are part of conversation now, and then they could be really taken into account. So far it seems like the thing works as expected, but I don't like a couple of things here. So what I don't like in the results here, we have some information fetched from the systems, but the thing is, I have no idea what's the place it comes from, right? I would prefer if the model would also mention where the information was taken from. And this is not here. Model is not clever enough to provide this information. If you check the output, it's not clear, for example, was last modified used at all? Was the confidence taken into account? We never saw the sources, right? Which file was that? It's very convenient if you have all this information put into the thread, so you can take also look at that. For example, the decision was made half a year ago. You don't remember details. And if you would see that, okay, this is from this architecture notes MD file, you can go there and check it on your own and bring something to the conversation. And this is the problem, like model takes something like a content, probably we see because it's there, but from other side it ignores a lot of attributes which may bring some value to the conversation. And this is the drawback of using TypeScript, by the way, because if you watched my video on Python and specifically on LangGraph Introduction, Python allows to create proper JSON definition where you would define every field and provide the description of every field and how every field should be used. And here we have the same thing, more or less, only for parameters, like we can define some parameter definitions here, but from the output perspective, we don't know, like we only can think that LLM is clever enough to do everything properly. And we don't like this. We want to have some still ways, workarounds, how we can make it better. So provide additional information to LLM how to better process our response. And this is something we're going to work on next. So which way we can provide this information to LLM, and again, it's pretty simple here, right? If you think about that, we are providing already the title, the description of the function, and description of parameters. And this is the only way how you can put something and send it to LLM. So what we need to do, we have to extend our function definition here. And it proposes something already for me. So what I'm doing here, I'm putting directly usage instructions. And here I'm saying some very important things about the response, and I'm asking to specifically take the content and use it for the making a decision. And the last notified field is here described, and the confidence also, and some useful information how to process those. And also I'm providing a response format, and this is kind of the same which you see here, but I added another field for instructions. So we have 2 points of information. First, we are providing basic information instructions from the function definition, and to be sure it's taken, we are providing the instructions back as a response from the tool. And this is kind of a workaround in the current situation we can do. Maybe in the future there is a way how to describe better, but for now the SDK does not provide that, unfortunately, so we have to do this workaround thing. And probably before we try and restart our server, next problem we would like to solve is this one. When we make a call, we have a query, and this happens because our LLM probably is not aware of different systems we have, or like it cannot categorize it. And also we can try and add this information here as well. And we're saying, okay, available knowledge systems, we have Jira, Confluence, Slack, Docs. And for now, this is a static list which I just generated, but in the future we will build a system, because this is a plugin system. We'll build a system which will be listing all the plugins and generating this available knowledge systems list automatically on a server startup. But so far it's a static list. All right, should we give it a try? I think so. And I'm going to Cursor settings and I'm refreshing the server, and now we have pretty comprehensive description of what this function is doing, and this should be self-explanatory for the LLM to just better process our system. And let's give it a try with the same request. And see, we have a system docs, so it says this is a documentation. Probably it's a physical file, so we don't care much about that at the moment, but it's better now, right? And let's check the response. There's another call for additional information because it doesn't know what this npx migration plan. A lot of questions from LLM. It's interesting. And see, this is the difference. It says according to this document, which was discussed, created, modified on this date, and this document have several agreements. So this is much better. This is exactly what I wanted to have here. And maybe before we finishing here, let's make it the last try and tell something like so this is a clear call to Jira system, and again I'm working on a Jira ticket with this number, and I'm asking the discussion how we should proceed with that. And let's check what's happening. And see, the LLM was clever enough to formulate the query, so it's a specific query, and system is Jira in this case. Alright, I'm not going to work to run the tool because we have this dummy response and it will confuse the LLM a lot, but you see the change of the behavior. Like, it was really clever enough to understand that, okay, system is Jira at the moment, and it extracted the ticket number as well. Alright, that was it for this video, and again, this is the first step. We are trying to build the real MCP server which can bring some value into your current work as a developer. And in the next lessons, in the next sessions, we will try to implement next things just to slowly progress to the final state. And it was me, Evgeny. Thanks for watching till the end. I hope you found something interesting in this video, and I will see you next time in the next video about MCP servers. See you and bye-bye.